Alright, so today I'm gonna finish this course right here. Let's see if I muted the site. I finish this course and then I might study. I'm probably gonna study the other topics, but I'm not sure if I'm gonna do that today. So yeah, let's see how long it will take to finish the course and then I'll think about it. So start running the timer. And let's start. Getting classy with C++. So far we've used several data types including int, double. Before I do that, let me open this up so I can write things down. Including int, double, standard string, and bool. When we work with int or standard string, we can create variables with certain properties and methods specific to those types. For example, int age33. So what happens when you want to create a type or something else? You can make your own. I think I did this already. You wanted to add a feature known as classes through the C language. A C++ class is user defined. Class serves as a blueprint for objects which are instances of the class, just like age is an instance of int. Yeah, I don't think I did this one. I think I just read the beginning. An object gets characteristics and behaviors from its class. You can create an empty C++ class like this in a header file. So this is the header class, create a class, so. And then you don't need brackets, and you need the semicolon. C++ original name was C with classes. I wonder if they have more courses also. Maybe they have more courses for free in Code Academy. But before I even do that, I'm gonna study the stuff. Class members. An empty class is pretty useless. Classes are designed to bring together related information and functionality. Time to add stuff inside. Components of a class are called class members. Just like you can add a string's length using length, you can access class members using the dot operator. There are two types of class members. Attributes, also known as member data, some information about an instance of the class. Methods, also known as member functions, are functions that you can use with an instance of the class. You use a dot before a method name to distinguish them from a regular function. We encapsulate or enclose for simpler user cases, attributes, and methods in a class like this. So it's just like any other function, any other language. Explain public later. This public doesn't exist on Python at least. Then have the attributes. Unless we have a mostly empty class, it's a common to split functions declarations from definitions. We declare methods inside the class in a header, then define the methods outside the class in a CPP file of the same name. How can we define methods outside of a class? We can do this using class name or the method name to indicate its class like this. So you create the class here, put the attributes, which are this. Then on the CPP file, you just type cd as it is standard. Because the standard is probably the class. Some class from that someone made to make things easier. And like with regular functions, we need to include the header file and the CPP file where we define the methods. So you need to include here song HPP. Class song this. Note, we must declare a method inside the class if we want to define it outside. Yeah, so we need to put this name inside of the class. Add the song class to the song PP. Inside the class, add an standard string attribute called title. Standard string title. Run. Build title and public on a new line. Now comes the methods. I think publicly is that it is gonna be publicly accessible to other functions, and private means that is supposed to be only on the scope of the function, maybe something like that. Not the function, the class. So private is when I believe you wanna have a method that is only used in the context of the class you're creating, and public is a method that everyone can access. I think every other you can access the method by using dot notation. Load title and public on a new line. We'll explain this part later. Add public. Add two methods declarations for song underneath. So let's see how to do that. There, you need to put the indentation. Add dot add title. Is that correct? I think it's just add title without the dot. A void method which accepts a new title for a song. Make sure this parameter has a different name than title. So standard string new title. Get title, which has no parameters and will return as standard string. So standard string gets title. Let's run this fast. Move over to song.cpp, add definitions for each method. Song add title. Choose set title to new title. So now I think I have to pass the parameter, but I'm not really sure. And then it's gonna be title equals new title. I'm not sure if I need to put standard string though before. Song get title should return title. Let's see if this passes. As ISO C++ forbids declaration of add title with no type. F permissive. Song add title string. Maybe if I erase this, it works. No, it gives me another error. Maybe if I do it, but then it's gonna give me a mistake here. Oh, so maybe inside of the parentheses, I need to put the function. Because it's like I'm activating a class. Not really sure. No F permissive. Our prototype for in song at title does not match any in class song. And you should put the brackets here. So here's not defined. You don't need to define the type of class. Maybe it's void. Maybe that's what I forgot. And now I need to put on the get title as well, which is a string. Nice. Always forget to put this before. Move over to songs space. Yeah, already did that. So next. Creating objects. Now that you have a class, let's create some objects. To refresh our memory, an object is an instance of a class which encapsulates data and functionality pertaining to that data. To create or instantiate an object, we can do this. City Accra. So city is the class, I guess. You can give the objects attributes values like this. Note that these must be attributes you define in the class. Oh, so city is Accra is an instance of the class city, I think, which is gonna have all those methods from city because it inherits from city. There we can access this information using the method we added to this city class if it's in a public part of the class. Flip over the song HPP and song CPP to see how the class and its methods are set up. Yeah, so we have add title, get title, same as before. Then in music.cpp instantiate a new song. So it's gonna be song. Electric relaxation. Okay, it works. Use songs built in. So every time you type something before, it is a class. So int is a class, boolean is a class, all the other ones are classes. I mean, they are programs that are built like this. They work in the back end with this, probably this library IO string. Use songs built in, add title, method to add a title to electric relaxation. Now you're gonna make, I don't know if you, I don't think you need to specify because it's already specified in the function of the class that is gonna be a string. But now is interesting because I don't know if it's dots or the brackets, I think. Or maybe you make it equal. Also, you make song dots. No, that doesn't make sense. Electric relaxation is the object, is the instance of the class. And now I need to put add title and then passing electric relaxation. And I think that's gonna work, probably. Okay, it doesn't. Let's see if I got it correct. Also, it was a typo there. Is the title you added electric? Also, there's also a typo here. What's up? Hey, you are the guy from yesterday, right? I think it is all 1900, something like that. I can't. No? It's very similar name then. Yeah, but the other guy showed up green, so I'm not sure how Twitch separates the colors. Yeah, I remember the other one was green, but I'm not sure if it's the same. Let's get title to retrieve Code Academy Pro. What do you mean? This is the free version of Code Academy. I don't think I can use the Pro on stream because, yeah, at least it doesn't feel right. I wish I could though. Get title to retrieve electric relaxation, title, and put it to the terminal. So I guess you just pass the name. No, maybe, oh yeah, you don't pass anything. You just got title. Learn Java? Where are you from? No, let's type it incorrectly. And I'm not sure if probably Code Academy has Java. Print out the title of electric relaxation. No, so I need to use standard count, I think. Maybe. Yeah, there we go. Access control, public and private. Let's circle back to that public keyword. What was that about? By default, everything in the class is private, meaning class members are limited to the scope of the class. This makes it easier to keep data from mistakenly being altered, and abstracts away all the nitty-gritty details. If you try to access a private class member, you get an error. But sometimes you need access to class members, and for that there is public. You can use it to make everything below accessible outside the class. So class public, step below is public. There's also private access modifier for when you want something below public to be private to the class. So yeah, this is public, this is private. Take a look at song HPP. We've added an artist attribute to song for you. So here, artist. In main, in music.cpp, try to add an artist attribute of a tribe called how long you program, try command, system out, printing sub. In the terminal, you say? I don't think I can Oh, in my terminal in the computer? Yeah, I'm not sure if I'm gonna try that because I don't know what's gonna do. And I don't have enough information. In codes, it doesn't let me do it. I think it's just the before I was able to do it, but in these lessons, so maybe if I do it in music, yeah, it doesn't work. But what does this command does? I suppose it prints sup. Not sure. Which is song for you? Main music split. Try to add an artist attribute of a tribe called Quas for electric relaxation. So it's also song electric relaxation dot the attribute, which is artist equals to a tribe of called Quas. Nice. You like types up in chat in Java. Oh, cool. No, check out that error message about song artists being private. Go ahead and remove the line you just added to main. To the main. Oh, I just did that in the previous one. Yeah, declare private here. So because it's not in public, it's private to the class. Go ahead and remove that line you just added to main. Oh, so they're asking me to remove from main. Because artist is private, you can't access it from outside the class. So what do you do? Well, you can move artists into the public part of the class, but then it's easy to accidentally restart artists and end up with some weird bugs. Better solution that allows you to interact with artists indirectly. Create a public.add artist for setting the artist. Create a public.get artist for retrieving the artist. So I think it's gonna be string, both of them. Add artist. And then it's probably gonna have a string here. New artist. And then standard string get artist. It's gonna be string. Oh, this one doesn't have a string. A parameter. So it still doesn't work. Yes, I got this card. My name is Grind. I don't remember the ID, but you can look below. I think I put it on Twitch. So much tabs because I study a lot of things. So usually I open up a bunch of things and then I don't close it because I want to look at it later. Function, no function reference, song at artist, basic string char, standard string, chart rates. So maybe I shouldn't put an argument here. So, well, I am passing a string. Oh, so I need to delete this also, which I forgot. But it's also giving me a mistake. No, thanks. Now, what is NSFW? Is it, how can you say that? An expression or acronym? I think is the name. I don't know. Chats that kinda only let's go. No, like rated R, something like that. Rated R. Because artist is private, you can access it from outside the class. What do you do? Well, you can move artists to the public. We're a solution that allows you to interact with artists indirectly. Create a public dot add artist for setting the artist. So maybe if I put string here again. It will work. Mm. Undefined reference. Test CPP, which is probably on the back end of the thing. Oh, I forgot the method. Maybe that's it. Yeah. We're setting the other artist. So here's add artist. And here's gonna be get artist. Returns artist. And here, oh yeah, it's gonna have this string as well. This parameter. Can't forget this. Well, apparently here you don't need it, but I'm gonna put it anyway. I think now it should pass. Hopefully. Yes, let's go. Uh, it's like chat that oh, I already read that. Not safe for work, but Google. Here, no Java chat. You like day 4? What do you mean? It's day 4 on the title because it's the 4th day I'm studying C++. In main, set electric relaxations artist through a tribe called Quest using so set electric relaxations dot add artist and then this string. Now we retrieve it and print dot get artist. Free invalid pointer. Hmm. This one seems to be correct. string here, string. Not sure what's wrong here. No, my discard name is grind with caps lock G. But I think in Discord I have to find it by ID. And I don't remember my ID. I usually leave Discord closed. And I only use it in the morning. Like when I wake up I check this stuff, post my routine in some group. And then I just close it. Real name is Victor. Grind with G. Exactly the way you typed it, but with G, caps lock G. Set electric relaxations artist to a tribe called Quest. I don't understand what I'm doing wrong here. Oh no, I created the object here, then add artist, and then I got artist. Let me try without this thing to see what happens. Same thing. Photo, you can check later. That's what that command do. Oh, okay. I will. Probably tomorrow when I wake up and open Discord again. That is probably, or imagine, since you mentioned rated R, something related to that. Something I couldn't probably open on stream, I imagine. Main set electrics relaxation artist show a tribe called Quest. Now retrieve the imprints. So the mistake has to be on the other files. Invalid pointer. So here is void. Oh, it's because I'm using string, not void, as the declaration. So because I didn't put a return here, then because it's a void, it's confusing because I'm using string as the class. Well, I should put void as well here. Because I'm not going to put any return, so he wasn't understanding that the function's there. Now it works. Nice. No, I'm good, man. Come on. Constructors, is there a way to give an object some data right when it gets created? We're so glad you asked. Constructor is a special kind of method that lets you decide how the objects of a class get created. It has the same name as the class and no return type. Constructors really shine when you want to instantiate an object with specific attributes. If we want to make sure each city is created with a name and population, we can use parameters and a member initializer list to initialize attributes to values passed in. So I guess it's pretty much the same concept as the other classes, where you can use init for Python and constructor for JavaScript. So class, you have the attributes, public, city, string name, city.cpp. Could also write a definition like this. So you just type the name of the class again. Members get initialized to values passed in, which are the arguments of the class, let's say. Okay, bye, man. Uh, However, a member initialization list allows you to directly initialize each member when it gets created. To instantiate an object with attributes, you can do a city, anchor, yeah, the same way as the other classes. The other classes now, the other languages. Now I have a city called Ankara with the following attributes. Ankara.name, set to Ankara. Ankara.population, set to this number. So new name, new population, and it's assigned here. Name and population. Just trying to see if I really understood this. Numbers get initialized to values passed in. Oh, so you can write it both ways. This one feels more intuitive to me than this one. And I'm also trying to understand. I think the difference between the methods or statements here is that from the constructor is that you don't need to initialize the class object with these ones, but you do need to initialize with these ones. Declare a public constructor for song. So HTTP, give it to standard string parameters, new title, new artist. Constructor here. So I think it's song, then standard string. And then I'm not sure if I need to do this, but probably they're gonna ask, which is title. Or maybe it's the other way around. No, here seems to be like this. Then define the constructor inside song CPP. Initialize title to new title and artist to new artist. So the initialization part is on CPP. I'm not really sure now. I think the constructor might be these statements on top here. But probably not, because on the other exercises, I didn't pass any arguments to create the class, the object, so. I'm gonna just gonna pass this here because I think that's the way you should do it, but I'm not sure on the HPP what I should be doing here. Because here it says city.cpp, so I don't think that goes on HPP. So maybe the only difference is that here I don't need to initialize it like this, and I can do the like this. Probably that's how it works. So it's wrong for some reason. Extra qualification song or member song. F permissive. So maybe I need to erase this. I needed to do at the end. Outwork command. Where are you talking about? Oh, maybe these ones I forgot. Yeah, there we go. Nice. Thanks. A song probably only needs to be given a title and artist once. Then you can set those attributes with a constructor. Go ahead and remove add title and add artist on song HPP. So add title, add other artist, add title. There we go. Let's try out your new constructor in main. Instantiate a new song. So I think was, yeah, like this. Go back to black. Give it a title of back to black. And an artist of Amy Winehouse. You can print out each attribute of black back to black using get title and get artist. So apparently I did something wrong here. The way that I initialize this. Oh, it's with the dots notation. Is it though? I'm not sure. I don't remember really well. Song. Let's see if they have it here. So to me, the way that it makes most sense is like this. It's not a member of song. Also, first I need to instantiate it. Oh, I'm gonna do that. Maybe I need to do song without the arguments first. I'll copy this so I don't have to write it again. Yeah, it doesn't work. Maybe it's a space and I don't have to put this. Let's see if it works now. It doesn't work. Yeah, but if I do it like this, it doesn't seem right either. So song name is the constructor, not the type. Yeah. Also, maybe it's just like this. So now I think it's correct. It's just the arguments that are left. Yeah, there we go. The next one. Destructors. So far we've learned how to create and use objects, but there's another part of the object lifecycle we need to cover, how to destroy them. It's actually far less nefarious than it sounds. Object destruction is really about tidying up and preventing memory leaks. The destructor is a special method that handles object destruction. Like a constructor, it has the same name as a class and no return type, but is preceded by this operator here that I don't know how to say, and takes no parameters. So I think that's different from the other languages. I don't recall that can destroy the constructor on other languages, but maybe I'm not correct. Inside, you add any housekeeping that needs to happen before the object is destroyed. You generally want to need to call a destructor. The destructor will be called automatically in any of the following scenarios. The object moves out of scope. The object is explicitly deleted when the program ends. Create a destructor for a song that prints goodbye plus the song's title. For example, a song with a title of drama should print the following message when destroyed. You'll need to include the IO stream header in songs.cpp for this to work. So I'm gonna do this right now so I don't forget about it. No. IO stream includes. Is incorrect here. Now it works. And they didn't talk about where do I need to put this, but here says CPP. Oh, add this song destructor here. So song, then it has this. Oh, actually is before. Then it should print something. Goodbye. And then I think it's title. Yeah, probably. So I have to declare it here. Oh, here. I think it's just doing this to declare. Yeah, now it passes. Next. That's an objects review. Hooray, you've learned the basics of classes and objects in C++. Classes are user-defined types. Objects are instances of classes. Class members are the data attributes and functions inside of a class. Creating a new object from a class is called instantiation. Class members can be designated as either private or public. They are private by default. You can create a constructor to instantiate objects in a particular way. A destructor allows you to execute any cleanup necessary before an object gets destroyed. We added a few files so you can create some of your own classes and objects. Include your header file here. So this should be include your class.hpp. Then here you can make, I don't remember if I have to include anything here. I remember seeing some stuff here. from the previous tutorials, but maybe just this IO stream. No, I already forgot. I think it's class that is written as music. And I don't think you need to specify a type. And you can put standard string, new song, standards. Oh, actually, let's do int, records, sauce, sales. The records. I could do a public, set records, void. Oh, actually, I don't need to put the definition here. New record. Then I will go here and I'll put void and music. I put I don't remember now how to say that is from the music class. Maybe I don't need to. I can just set it right away. But I think I need because, or maybe I need to call the HPP here as well. Yeah, that's probably what I need to do. Record equals new record. Here I'm gonna print just to see if it works. Oh, actually, music. Uh, let's do Chupak. Shukur. I don't know. Just give any name. So I'm gonna do about the constructor first. Oh, and another thing, it this stuff is required. Oh, there that I remember. Oops. Then I'm gonna do standard count. Chupak. Dot records. No dot. New song. It's not printing anything. Because I probably need to put another method to return. Now I'm confused. Oh, actually here there's no parameters. the definition that the parameters come. Well, actually, here there's no parameters as well, just the return. Oh, actually, here I need to put song. Yeah, record equals new record. So here I need to put record, and here I need to put return record. See if it prints anything. And I get records. Records. Doesn't work. Huh. Maybe because it's private, so it doesn't return. But it should be giving me a mistake. Or because I need to set the record first. Doesn't say anything. So what am I doing correctly here? Quitting Chupac, which is a class music, calling set records, place a new record. True hello, which is gonna activate this. It's gonna make record equals new records. It should be returning the name of the records. Oh, no, set record and record. It's confusing because they put records here. Label. And we need to compile them together. That's the problem. In function void set records. Record was not declared in this scope. Record equals new record. So I'm probably doing something wrong for the class. So I think it's music here. That's what I'm forgetting. But I'm not really sure. And now it works. Nice. So it works. So running from here doesn't work. It's because you have to compile both of them so that the compiler links the files. Now it works. Nice. And I also wonder if I can do the old thing to change the name when I want to call. Class.spp/o hi. Then I just run hi here. Hi. Yeah, there we go. Nice. Just to remember that command. So now I need to do the constructor here. It's gonna be in public. It's gonna be music / music. The destructor is gonna be same thing, but with this stuff here. And standard codes. Goodbye. Oh, but that's not here. Keep forgetting. Here's just the declaration. Now here is the part. I remember how to do it this way, but I don't remember how to do it the other way. That is slightly more unfamiliar for me. So I think I need to pick up these things here to initialize with these attributes. And I'm gonna make label equals 0 and record equals new record. And this should work as the constructor. So now when I call this, I need to instantiate with, well, but then, yeah, it's gonna be 0 by default, but then you can make something else if you like. So the first thing is the record, which is a string. Which is gonna be changes. And here is gonna be label, which is an int. Not sure if I can do it like this. Yeah, it still works. Let me see if I do it. I do this thing here. It's still printing hello. Maybe it's just a terminal. Uh, if I open a new one. No, it might be the terminal. I'm not sure, but it should be giving me changes here. Turn records. So I suspect it's just a problem with the terminal. Let me erase this line and see what happens. It's probably not going to change anything. And now it changes to label. Yeah, but well, doesn't hurt to try. So label is giving me a mistake. I guess I should pass a number. Press 4. I'm still giving me a mistake. Hmm. So the mistake is on the constructor for sure. Extra qualification music on member. I can't see. Member music, F permissive. Oh, maybe it's the indentation. No. Oh, let's check now. On this. So it still doesn't work. Oh, maybe that's the reason. Uh, oh, I need to put the things here, the arguments, the declaration. That's the problem. And this one doesn't take any, so suspect I don't have to put. But then maybe I need to declare that is void. Let me try to. I don't remember if the constructor and the destructor needs to have the class, the type specified before. My gut instinct tells me not, but It's still giving me the same mistake. So maybe I should go back and redo the lessons, because I clearly don't remember really well. Or maybe just the terminal again, because it's giving me exactly the same mistake, although, even though that I changed the files. Well, I can close this one and open a new one. So I wonder why it was working before. Extra qualification music or member music. So I'm gonna go back and check the constructor part again. City. Yeah, it's doing the same thing that I did. But this is on the CPP file. No, it's just song and then. So it doesn't have the other stuff. I think now I get it. So I need to erase this. But then I'm not sure about the destructor, but. And here I think it's fine. Maybe don't need to declare the destructor. Sure if that's the right way to. 93%. I think I'm gonna move on because it's not loading there. Introduction on computers. Memory is a sequence of bytes. We can number the bytes from 0 to the last one. Each number, known as an address, represents location in the memory. Everything we put into memory has an address. For example, when we declare and initialize an int variable named power, this will set aside an int size piece of memory for the variable power somewhere and put the value 9000 into that memory. But where is somewhere? How is it useful? This lesson we will answer these questions by learning about references, pointers. These are some of the most powerful features in C++. They allow programmers to directly manipulate memory, the most critical and scarce resource in computer, in order to optimize performance. However, references and pointers are also sometimes considered two of the most complex and difficult features in C++. So let's get started. Yeah, that's the bitwise stuff that I was having trouble understanding. References in C++, a reference variable is an alias for something else. That is another name for an existing or for an already existing variable. So suppose we make Sonny a reference to someone named Song Call. You can refer to the person as either Sonny or Song Call. Let's take a look at how we can do this with code. Suppose we have an int variable already called this, and we create an alias to it by using the and sign in the declaration. So here we made Sony a reference to Song Kao. Song Kao. Not sure how to say that. Now when we make changes to Sony, add 1, subtract 2, etc. Song Kao also changes. Two things to note about references: anything we do to the reference also happens to the original. Aliases cannot be changed to alias something else. So after you initialize it, it's already put together. Variable called soda declared initialized line 9, declare another int variable called pop, and make it a reference to soda. So int and this thing here, pop equals soda. Let's add a bunch of pop. Pop plus equals 1. Print out soda and pop. I think I can do it in the same line. It's easier, but maybe it doesn't pass. Yeah, 100, 100. Yes. Well, here neither of them went up, so maybe I did something wrong. So maybe I can't use plus equals here. It's still the same thing. Oh, it should look like 100, 100. Even though we added a bunch of pop, the variable it referenced soda also went up by 1. Oh yeah, it's because it's 99. Yeah, tripping. For some reason I thought it had been initialized to 100. Passed by reference. So what's a good use cause for references? Let's take a look. Previously, when we passed parameters to a function, we used normal variables, and that's known as pass by value. But because the variables passed into the function are out of scope, we can't actually modify the value of the arguments. Pass by reference refers to passing parameters to a function by using references. And call the function can modify the value of the arguments by using the reference passed in. This allows us to modify the value of the function arguments, avoid making copies of a variable object for performance reasons. The following code shows an example of pass by reference. The reference parameters are initialized with the actual arguments when the function is called. So, like this. Yeah, this is starting to get really confusing. Notice that the int I and int j are the parameters of the function swap num. When swap num is called, the values of the variables a and b will be modified because they are passed by reference. Output is a is 200, b is 100. Suppose we didn't pass by reference here and have the parameters as simply int I and int j in the swap num function, then I and j would swap, but a and b wouldn't be modified. So when you initialize outside of the function, you have to put this symbol so it changes the values, the initial values, outside of the function as well. To reiterate, using references as parameters allows us to modify the arguments' values. This can be very useful in a lot of cases. So whenever you use this, it means that whatever argument you call when you pass the function can be changed by the function. So it's kind of like in this statement, I think. This and self, this for JavaScript and self for Python. Because when you pass something with the this statement, I think is the same thing. That it retains the scope of execution, I think. Not sure. Take a look at the program in the code editor. There's a function called triple, and there is a main where we call triple twice. So triple main triple twice with num is equal to 1. So it's gonna return 3 both times now, I suspect. I think we'll run the program to see if we're correct. Yeah. And then they want me to put this stuff, so it returns 9. Because it's gonna retain the value. Yeah, so I think it's easier to understand for me because I already took a bunch of time trying to understand this concept. It's still very confusing, but at least I'm sort of grabbing, starting to understand. That's by reference with const. Remember const? The const keywords tells the compiler that we won't change something. For example, in the following code, we're telling the compiler that the double variable pi will stay at 3.14 throughout the program. If we try to change pi, the compiler will throw an error. Sometimes we could use const in the function parameter. This is when we know for a fact that we want to write a function where the parameters won't change inside the function. Here's an example. So it's gonna same concept from JavaScript. In this example, we are not modifying the I. If inside the function triple the value of I is changed, there will be a compiler error. So to save the computational costs for a function that doesn't modify the parameter values, we can actually go a step further and use a const reference. This will ensure the same thing, parameter won't be changed. However, by making a reference to the argument, this saves the computational cost of making a copy of the argument. I'm not sure if I understand the last part. Take a look at the program in the code editor. There's a function called square. There is a main where we call square once. So it's gonna call square of 5. Should return 25. Int run the program to see if we're correct. Since we are not modifying the parameter in the function, let's go a step further and make the square parameter as const reference. Run the code again. So now I'm not sure. No, the output should be the same. So since we are not transforming I into something else, we can make it a const. So it makes the value fixed, and then this symbol makes it so every time you call it, it's gonna be this fixed value here. Because if you didn't call, if you didn't put const, it would be 25 times 5, which is 125. And because you put const, it doesn't change again. So it's a way to make the side variable becomes points towards the same variable of I, but I doesn't change inside of the function. I think that's the logic here. It's kind of hard to understand why not use just int. Seems like they're there's a counteraction there. So I think the only explanation that makes sense is that you want to point the side to a different place in memory. It's gonna be I. But you don't want I to change. So what happens if you call side with 10? If I call square of 10? Always gives 100. So it does change this, it's not giving 25. Yeah, whatever. We're gonna go to the next one. Memory address. So we have learned about references, aliases, which are created by using the and symbol in a variable declaration, but the and sign can have another meaning. Regardless of operator and is used to get the memory address. The location in the memory of an object. Suppose to declare a variable called. Have you wondered where this variable is stored on the computer? We can find out by printing and pop porcupine count. We return something like this. This is a memory address represented in hexadecimal. A memory address is usually denoted in hexadecimal instead of binary for readability and conciseness. The meaning of the and symbol can be tricky at first, so make sure to denote. When and is used in a declaration, it is a reference operator. When and is not used in a declaration, it is an address operator. Okay. So the function changes depending on where you're putting it. And hexadecimal is pretty much the same as binary, but is for base 16, which means that uh, each place here is going to be 16 elevated to the position that the number is in. So here 16 elevated to 0, then 16 elevated to 1, if I remember correctly. Yes, 16 elevated to 0, 1, 2, 3, 4. But I'm not really sure if that's the case. I remember it's base 16, but I don't remember exactly the conversion. But yeah. In the code editor, we have already declared and initialized a variable called power. In the memory address, power is in standard count. think I need to review hexadecimal maybe. Yeah, I think it's 16 elevated to whatever position it is times something. Times the number that is expressed there. I don't remember really well. Pointers in C++, a pointer variable is mostly the same as other variables, which can store a piece of data. Unlike normal variables, which store a value, this is an int double char. A pointer stores a memory address. So a variable store values, and pointers store memory address. While references are a newer mechanism that originated in C++, pointers are an older mechanism that was inherited from C. Recommend avoiding pointers as much as possible. Usually a reference will do the trick. However, you use pointers a lot in the wild, particularly in older projects, where they are used in a very similar way to references. Pointers must be declared before they can be used, just like a normal variable. They are syntactically distinguished by the asterisk, so that int star. Int star means pointer to int, and double star means pointer to double. So suppose we have a variable called gum. You can create a pointer to it by int pointer gum. Int makes it pointer rather than a normal variable. Pointer is the pointer name. Gum is the memory address of the other variable gum. So now pointer has a value of gum's memory address. And let's look at this game. Can you give me a few pointers? I hate you. The address. Note synthetically spaces around star do not matter, but the best practice is to have it after the data type. So I guess the last one is the best practice. Oh, so it doesn't matter. Oh, I think the best practice is the first one, probably. I don't know. This is the one used here. The code editor, we have already declared an initialized variable called power. Create a pointer called pointer that points to the memory address. So int pointer and power. Now I need to print. So the pointer is gonna save the location in memory of the variable power. The reference. So now we learned what a pointer is and how to create one, but is there a way to obtain the value pointed to by the pointer? The RC sign, aka the dereference operator, is used to obtain the value pointed to by a variable. This can be done by preceding the name of a pointer variable with star. The meaning of the star symbol can be tricky at first, so make sure to note. When star is used as in a declaration, it is creating a pointer. When it is used in a when it's not used in a declaration, it is a dereference operator. So it's similar to the AND operator in that sense. Print out pointers with using standard counts. So it outputs the value of the memory address. Yeah, I understand it right now, but I'll definitely forget this stuff with time. So I'm probably gonna need to review this. What's the name of this stuff? Pointers. That's the name of the end operator. Let me go back on the lessons memory address. Pointers and reference. Yeah, that's enough. No pointer, when we declare a pointer variable like so, its content is not initialized. In other words, it contains an address of somewhere, which is of course not a valid location. This is dangerous. So yeah, it's dangerous because you don't know where it is, maybe. You should initialize a pointer by assigning it a valid address. But suppose we don't know where we are pointing to, we can use a null pointer. Null pointer is a new keyword introduced in C++11. It provides a type-safe pointer value representing an empty pointer. You can use null pointer like so. It's just assigning to a variable. Maybe it's a special keyword. In other C code, null was used for this purpose. Null pointer is meant as a modern replacement of null. Change the declaration of pointer and initialize it to null pointer. Okay, next. Review. Congratulations, I have officially done it. In this lesson, you have learned references, pass by reference with const, memory address, and how to access them, pointers, dereferencing a pointer, and null pointers. As a final send off, do you remember you wrote a letter in the first lesson of the course? Well, here it is. You have come a long way and should be very, very proud of yourself. Thank you for taking this course, and we can't wait to see things that you will. Nice. So I think it's done. Dear yourself, post for myself, learn C++, and eventually build my own artificial intelligence library. So this was on day 7. How long did it take? 1, 2, 3, 4. Yeah, 5 days. I did actually 4 days because I didn't stream on Wednesday. So 4 days to finish the course. So they do have more, I think, but it's probably competition with Pro. It's probably paid stuff. Or this is probably the one that I did it already. And this is if you pay the Pro version. So let me see if they have more courses. Intermediate course. So maybe I can do this one also. If it's free. And the basic that's how to work with object-oriented programming, C++ built-in data structures and more. Getting started, basic syntax, control flow, functions. C++ built-in. So this is intermediate, so I guess is advancement. on the other one. I don't know, why care about style. Exclude statements, naming conventions. So it's just a bunch of articles. Yeah, it's probably paid. Learn about the basic program structure of C++ program. Yeah, so it's probably stuff that I have to pay. I'm gonna close this down. Still have 17 minutes. Yeah, I'm kind of already tired because this part of the course was harder than the previous ones. I should think more. So I'm not sure if I studied something for the last 17 minutes. So I think this question I already know because the rest of the course. So pretty much the explanation is that standard is a class. Yeah, but then every time you wanna do something with standard, you do this. So maybe I'll watch a video about this. I think I'm gonna go one topic at a time.
Hey, what's up guys? My name is Eterno and welcome back to my Hey, what's up guys? My name is C++ series. Today we're going to be talking all about operators in C++ and operator overloading in C++. So first of all, what's an operator? Well, an operator is basically some kind of symbol that we use, usually instead of a function, to perform something. So I'm not just talking about mathematical operators that we have, such as plus, minus, divide, multiply, all that kind of stuff, but we also got other operators that we use very commonly, and we've actually been using quite a few already. These include things like the dereference operator, the arrow operator, plus equals, there's the ampersand operator that we use for memory addresses. We've also been using the bit shift left operator, which is two left angular brackets for printing out stuff into our cout, into our console. And then we've got other operators which you probably don't think of as operators at all, such as new and delete. They're also operators. And then we have entirely different operators which are weird, such as the comma operator. Yes, the comma can also be an operator, as well as parentheses. Yeah, that's right. Two like brackets, two parentheses. That's also an operator. I'm not going to list off all the operators we have available in C++. I will make videos, specific videos about some of them because they need some talking about. But if you want to see the full list of C++ operators that exist, then I've linked a reference in the description below. So operator overloading, what does that mean? Well, the term overloading in this sense just means kind of giving a new meaning to, or adding parameters to, or creating, essentially. In the case of operator overloading, you're allowed to define or change the behavior of an operator in your program. This is a very, very useful feature that isn't supported in languages such as Java. It is partially supported in languages such as C#. Usually the good parts of it are supported, but C++ kind of gives us full control. And that's it's kind of a good thing, but it can also be a bad thing. And that's just the case with C++. It gives you so much control that it can lead to so many bad programs and people hating on the language. I might actually make a video just talking about all this because I know that a lot of people are interested in that. But at the end of the day, operators are just functions. They're just functions. Instead of giving your function a name such as add, you can give it an operator such as plus. And in a lot of cases that really helps to clean up your code. If it does, then you've probably all the results, say, over here. So I come to the problem of what do I write? Well, in a language without operator overloading, or if you're in C++ but you don't want to use operator overloading, then you would probably write something like position.add speed. So if we go up here, we'll quickly define the add function. It's going to return a brand new vector 2. We'll call the function add. It's going to take in an existing vector 2. We'll pass this
So I didn't learn this struct thing in the course.
const reference to avoid copying. We'll mark the function as const since it's not going to modify this class. It's just to be the multiplication operator followed by the operator, which is operator. And a lot of people actually don't know about this because, again, it looks a bit weird, but totally videos on operators as we use them or as I see stands for output strings, the reference.
Also, I don't think there's tuples in C++, just lists.
Original kind of definition of this operator that I'm overloading here. We're going to write operator left shift. Inside here,
Lists and dictionaries are objects.
we're going to take in the class because you can see this is a definition outside of the class, so we still need a reference to the existing stream, which in this case is going to be cout. And then I'm going to pass my const vector by reference here. Over here I'm going to say stream and then shift basically whatever I want to print. So in this case other.x, the stream already knows how to print a float, so we don't need to overload the float or anything like that. And then maybe a comma and then other.y. And make sure that you want to compare results. You can see that works. Don't do it that way.
He's not talking about what I want to know.
Mr. Cherno, welcome back to my C++ series. So today we're going to be continuing on with our whole move semantics journey. If you guys have not seen the other videos in this kind of little mini series, then definitely check them out. I'll have one linked up there that's going to be about move semantics in general, but use it, when do we need to use it, and then also something called the move assignment operator. And this is specifically an assignment operator that we use when we want to move an object into an existing object. So we've covered move constructors, or a move constructor, that's what we did in the last episode. However, what we haven't covered is what happens if we, instead of constructing a new object, we want to move an existing object into another existing object. And that's what we're going to be talking about today. But first, this video is sponsored by Skillshare. You can actually watch value episode where we look to move semantics in general, and let's upgrade our string and entity class to be able to handle move assignments. And we'll also be talking about std move while doing that, since that's an important part. So this is the string class from the last video, and here's our entity class as well. Let's first talk about std move and what it does. I'll actually use string as an example here, just because we seem to have this kind of, we have two classes. We have string, we have entity, and entity is like an extra level of interaction. Entity itself, in fact, is an example showing how to use string, which is the real thing we're interested in moving. So what happens here when we decide to actually take in a string as a temporary here is we're using std move. And this is from the last video. We had to use it because this was a way for us to move this name temporary, which we're providing over here, into this kind of more or less permanent spot for it to live in. If I simplify this by writing it over here, I'll create a string, and I'll just set it to hello over here. So now I have a brand new string. What happens if I want to move it into here? Maybe this is the destination for my move. Well, I could assign it like this. However, what that's doing is copying the string into this new destination variable, of course. So what do I do if I want to specifically move it into this new variable? Well, I have to make it into a temporary, because that's what the move constructor takes, right? If we look at the string constructor here, we have this one, which is our move constructor. This takes in an r-value reference, which is a temporary object. So in other words, it's really simple. I have to make it use this constructor, because this little blob of code here is what actually steals the resources from others. So in other words, that's the thing that actually does the move. So the thing is, we're creating a new object here. This is an existing variable. Reference, we'll write operator equals, which is our assignment operator.
Not talking about what I want to understand. Maybe I should search for IO stream. Yeah, this is the library that is using character in, character out, center output stream, center output stream for hours, center input stream, center outputs stream, center output stream for hours, center output stream for logging. But this doesn't talk about the standard thing. Oh yeah, I forgot namespace as well. think I'm gonna watch the video. We'll study this stuff later.
So hello everyone and welcome to this new video tutorial, and today we're going to discuss about how you will pass a function name as argument to another function. So like just the way you do in your callback functions in the APIs like Win32 or the direct library for OpenGL. So you just what you do is you pass a function name as an argument, which is to be registered as your callback function, which you desire, which is to be called for the callback. And so if you you might have wondered that how the function names are taken in as the arguments and what the formal parameter list of these functions may look like. And so let's clear the doubts here and let's get started. Now, if you want to pass the functions as arguments, so you need to be familiar with a concept which is the function pointers to function types. So you might have used pointers to different types like all the built-in types in C++ or the other user-defined types. And if you don't know anything about C++ pointers, I strongly recommend to go back to the tutorials and learn something about pointers because they're going to be used in this tutorial. And now coming to function pointers in C++, which I'm going to teach you here how to use the function pointers, because this is the only way we can pass. Might be another ways of passing, but this is the way I recommend for passing function integer. So first thing will be return type, and then you will give a name to the function pointer, which is to be like asterisk sign is to be used before the function, the parameter list of the function which the pointer is going to point to. So this is also fixed like the return type, and for now let's keep it void, no parameters, or you can just empty braces. So func is now you can say that the func is a pointer to a function that returns integer and takes no arguments. Or now, for instance, you'll just keep it void here because this will now point to a void function. For just to keep it simple, and now you can define a similar function which we'll call func1, the similar syntax as the pointer points to, and let's make it print out hello on the screen. And now you can use a pointer to call it. Now you can assign func1 to the func pointer, which is the syntax is the same as you do for other pointers. So the pointer name followed by assignment operator, and then the ampersand operator, because we need the address of the function 1. And so now the func pointer points to the func1, this function. And now if you call the func, the pointer is being called, so this points to func1, so this function will be called now through this pointer. And now if you build and okay, I just messed up here. And now if you build and run your program, you should get this output, which is reprinted by func1. And you can see here the function being called is a pointer. So you're calling the pointer which is calling the function which is pointing to, which is the func1. And so now that you're familiar with pointers to functions, now you can proceed in the topic of passing functions as arguments. So now I'm going to declare a function which returns integer. The function name is call, and this function will take another function as an argument. So the function which is to be taken as argument has a return type integer, and now we give it a name to the pointer, takes in a function as in passed while you're calling call function. So first the function name and then the argument which is to be passed to the function. If you're not understanding this, you'll just see the upcoming code and this all will be clear. Used to call returned by the function and by the variable passed to it, so we can call the
It starts to get confusing really fast.
I don't have to just call other functions from inside main. I can actually call them from within functions. So I've got my function called drawBar that just draws a line of length, whatever specified with whatever symbol is specified by mark. And I can make another function. Let's call this guy cube, and it's going to need a length and a mark. And what I can do is I can have cube call drawBar in order to draw a square on the screen. So what I'm going to do is I'm going to loop from 0 up to length again. And I'm going to, every time the loop goes, call drawBar. And this guy needs his actual parameters passed to it, and it's going to be length and mark again. And then what I can do from main is I can call cube. So let's say cube, let's make it a 5 by 5 cube, and let's use, how about @ symbols to draw it. All right, let's see what that looks like. I'm still running from previous time to get rid of that. All right, run, go. So now I have a cube built out of @ symbols, and this function didn't re-implement the stuff that was already implemented in drawbar. It just made use of it to its advantage. One more thing about functions. When I create the function heading, the top line of a function, these guys are referred to as formal parameters. When I call the function, as here I'm calling drawbar, and I pass it to values, these are called actual parameters, or sometimes you'll hear them called arguments. It's just a little bit of terminology for you. And in main, I could again hand this guy variables. It wouldn't matter if I'm handing it variables or literal values when I'm passing by value to a function.
So I think I'm gonna change this. Library of standard methods. Because I want to understand how these methods work. The string, void, int. Where do they come from? And for function declarations, use pointers. So I think what I'm gonna do stop this now. What I'm gonna do is stop here, and then I will study these topics here one by one. Another time, once I feel like I got at least somewhat of a grasp on them, I'm gonna go stop studying C++, start studying, finish the SQL courses on Kaggle. Then once I do that, then I'm gonna build the library, a very simple library on Python of artificial intelligence using the low-level API, because he talks about it in the book and he explains very in-depth how to do it. So I'll probably take the book and do it with the book on the side. Once I have the library of artificial intelligence, I think I'm gonna also read a little bit, explore a little bit of the functions inside the TensorFlow library. Then once I do that, maybe I should write this stuff down somewhere. So first, study topics notebook file. Finish SQL courses on Kaggle. Build simple library Python using the book, using TensorFlow level API. Let's reference. Then after I do that, go back to the file and study the rest of the topics. And here I'm gonna put compiler as well. Oh, that's compiler. I put compiler here. So I'm gonna do these topics, do the other stuff, because I want to separate them so that, because I'm probably gonna forget a bunch of stuff after I study this. Then once I come back to it, I'm gonna be forced to rethink about it. But I think these are more general topics as well. Though once I come back to this, go back to the file, study the rest of the topics, then build the AI library with C++. Oh, actually, I forgot to stop. Which is to yes. Explore TensorFlow. Library files using the inspect search. Yeah, I think this is good as initially. So when I come back, I'm gonna do this stuff here. Study this stuff. So see you next day.